Number 1 asks us to rewrite each equation so that the expression on one side could be graphed and the x-intercepts would show the solutions to the equation. So when we're on a graph, the x-intercepts are on the x-axis, right? And that x-axis is actually where all the y values are 0, or where our function is 0. So we want to get our expression to be equal to 0, then our solutions will be the x-intercepts, which means you just need to bring everything onto one side of the equal sign. So in part A, I'm going to subtract 81 from both sides because 81 minus 81 will be the 0. And so then on the left side, we get 3x squared, which we originally had, and then we have minus 81, which are not like terms. So we'll just write them next to each other like that. Then we have the equal sign, and 81 minus 81 is 0. So we'll be able to graph that and look at the x-intercepts. For part B, now you can make this complicated if you want to. I'm not going to, because if we were going to be graphing this, we would be using a graphing calculator or some graphing website like Desmos. So I'm just going to leave all of this stuff the exact same. I'm not going to do anything to multiply it out. I'm just going to get this 5x and I'm going to bring it to the left side. So I'm going to subtract 5x from both sides. Now, you have a lot of things on the left side already, but leave them exactly as they are. So just leave it as x minus 1 times x plus 1, and then you have the minus 9, and now you'll have a negative 5x. And then on the right side, 5x minus 5x is 0, and you'd be able to type this into your graphing calculator and find the solutions. Your graphing calculator or Desmos doesn't need it multiplied out. So easy enough. Then C, so subtract 32 so that we get that side to be 0. So then on the left side, we have x squared. We have the minus 9x. Now this time you have a 10 and a negative 32, which are like terms. You could just leave it as plus 10 and minus 32. I'm going to combine it to negative 22. And then 32 minus 32 is 0. And then D, we'll subtract 29 from both sides. So again, I'm going to leave this left side exactly the same. So I'm just going to leave it as 6x times x minus 8. And now I've got this minus 29 that I'll put on the end. And then on the right side, 29 minus 29 is 0. So then we'd be able to graph that and find the x-intercepts as the solutions. Number 2, here are equations that define quadratic functions, f, g, and h. Sketch a graph by hand or using technology that represents each equation. So if you're not sure how to graph these without a calculator or Desmos, go ahead and graph them there so that you can see. But x squared plus 4, I know just moves the graph up 4 units. And I know that a quadratic and x squared looks like this. So this time I know it's just going to move up 4 units. So the vertex is going to be here. And then we're going to have branches that go up on either side. So that's going to be my sketch of that one. For g of x, I know that zero product property, these would be intercepts, the numbers that would make these 0. So I know this is going to cross at 0. I also know it's going to cross at negative 3 because negative 3 will make this part 0. And then I know again that it's a quadratic, so it's going to go something like this. And then for h, zero product property would tell me that this is going to cross at x equals 1, and that's the only solution. It's also positive, so the branches are going to be going up when I sketch them. Then it says determine how many solutions each f of x equals 0, g of x equals 0, and h of x equals 0 has, and explain how you know. So remember that this first one was f of x, and it doesn't cross the x-axis at all, and that's where our function equals 0. So this is the line y equals 0, or f of x equals 0, and our graph doesn't cross that at all. So this f of x has 0 solutions. g of x crosses the x-axis twice. So this one was g of x. So g of x has two solutions. And then h of x crosses the x-axis once. So h of x has one solution. Number 3, Mai is solving the equation x minus 5 squared equals 0. She writes the solutions are x equals 5 and x equals negative 5. Han looks at her work and disagrees. He says that only 5 is a solution. Who do you agree with, and explain your reasoning? So we can just, maybe you have an idea already. Otherwise, we can just take these two solutions and plug them in and see if we agree with Mai or with Han. So if we do 5 minus 5 squared, that's that first solution here. And 5 minus 5 is 0. 0 squared is 0. So this one is a solution. So we definitely agree with x equals 5 as a solution. Then we can go ahead and plug in negative 5 and see if that's a solution. So then negative 5 minus 5 squared. Negative 5 minus 5 is negative 10. And negative 10 squared is 100, which does not equal 0. So that means that negative 5 is not a solution. And that means that we agree with Han because only x equals 5 is a solution. Number 4, the graph shows the number of square meters A covered by algae in a lake W weeks after it's first measured. And then a second lake, so this is our first lake. And then in a second lake, the number of square meters B covered by algae is defined by this equation. So lake B, or the algae covered in our second lake, is here, where W is the number of weeks since it was first measured. For which population is the area decreasing more rapidly? So we want to look for the growth factor in each of these. So the growth factor in the equation is pretty easy to find. Okay, it's just the number attached to the variable. So in the second lake, the growth factor is 2 over 5, which as a decimal is 0.4. Or as a percent is 40%. So each time there's only 40% of the algae remaining. Then in the first lake, we would want to calculate the growth factor because they give us just our ordered pairs or our dots. And so remember, we need to take a new measurement divided by the original or the one before it. You really want to do two consecutive numbers. So 0 to 1 is the one I like to do, but you can do 1 to 2, 2 to 3, whatever. And so I'm going to take these two. So the new one, and if we look, this is 1, 2, 3, 4, 5. So 100 is split into 5. So each one is 20. So the new amount remaining is 120 versus the original amount was 240. And this simplifies to 1/2, which as a decimal is 0.5, or meaning 50% of the algae is remaining after each hour. So then this question asked us which area is decreasing more rapidly. So this is how much is remaining. So the smaller of these numbers is the one that's decreasing most rapidly, because this is losing 60% each time or each hour, since it's keeping or retaining 40%, where this one is losing 50% each hour. It's keeping 50% and it's losing 50% each hour. So this lake B is losing 60% each hour. So lake B, or the second lake, would be the one that's decreasing most quickly. Number 5, if the equation x minus 4 times x plus 6 is true, which is also true according to zero product property. So remember, zero product property says that if we have two quantities or more that are multiplied by each other and they equal 0, okay, one of these or both of these factors or the numbers being multiplied has to equal 0. And in this case, our factors are x minus 4 and x plus 6. So either x minus 4 is equal to 0 or x plus 6 is equal to 0. And we see that in option C. Number 6, solve this equation, show your solution or solutions are correct. So we want to isolate the variable here. So we have 4 times z squared. And so we want to undo multiplication by 4. So we undo that by dividing by 4. So we get 25 divided by 4 equals 1z squared, or just z squared, because 4 divided by 4 is 1. And then undoing a square root. So the opposite or the inverse of squaring is square rooting. Okay, so to undo a squared, we do a square root. And remember that when we square a number, whether it's positive or negative, okay, it's going to come out the same. So we want the plus or the minus square root of these numbers. So then we end up with, and I'm just going to write the z on the left side. So then we end up with z equals, and you can square root the top and the bottom here. Okay, so I'm just going to put the plus or minus out front. And then I'm going to look at this as the square root of 25 over the square root of 4. So that's a property of square roots, that you can square root the top and square root the bottom separately. So then we end up with z equals positive or negative, and the square root of 25 is 5, and the square root of 4 is 2. You also could have just done this in decimals. Okay, so you could have done 25 divided by 4 as 6.25, and then done the square root of that, the plus and minus square root of that, and gotten plus or minus 2.5. That's also fine. Okay, so either of these solutions is fine. Then you want to go ahead and plug it back in to your original equation to show that it works. So we've got two solutions. So I'm just going to write this out twice. And then you can plug in whether you did the fraction or the decimal. If you're doing the decimal, then you're just using your calculator. So I'm going to plug in the fraction. But again, feel free to plug in the decimal into your calculator. So now if we go ahead and we use order of operations here, that would say that we're going to square both the top and the bottom here. Okay, so we're going to do 5 squared, which is 25, 2 squared, which is 4. Then we would multiply that by 4, right? And this 4 would cancel with this one. Or you can think of it as 100 divided by 4, and you end up with 25, and we see that that is a solution. Okay, so positive 5 over 2 is a solution. Then we're going to go look at this next one, and we'll simplify this. So again, we will square the top and bottom. So negative 5 times negative 5 is positive 25. And then 2 times 2 is 4. So I dealt with that exponent. Then we'll multiply the 4 times 25 fourths. So we get 4 times 25 divided by 4. So those 4s will cancel out to 1. So we end up with 25 equals 25 again. And that says that negative 5 over 2 is a solution as well. Number 7, to solve the quadratic equation, 3 times x minus 4 squared equals 27. Andre and Claire wrote the following. Okay, so you can see what they wrote. And you want to identify the mistake each student made. Okay, so both of them are making mistakes. So let's take a look at Andre's. And so when we look at this first step, we see that this 3 is gone. So he divided both sides by 3. And 3 divided by 3 is 1. So we just get that x minus 4 squared. and 27 divided by 3 is 9, so that's good. Okay, so his first step is fine. Then the second step, when he goes from here to here, he just distributes in the squared. So he's saying that x minus 4 squared, we can just bring those squareds in, and that is false. Because remember that x minus 4 squared is really x minus 4 times x minus 4. And then we can either use the area model, or you're multiplying x times x to get x squared, x times negative 4 to get negative 4x, then distributing the negative 4 to both. So getting negative 4x and then positive 16. So that's where Andre went wrong. And then when we look at Claire's, okay, so Claire did the same first step as Andre, dividing by 3. So that was fine. So she isolated the squared part. Whoops. Then when she went from here to here, she's got rid of the squared, but she says that x minus 4 has to equal positive 3. And remember that this piece in here that's squared could equal positive 3, or it could equal negative 3. So she's missing the solution where it would be negative 3. So that's Claire's mistake. And so I'm just going to work from Claire's, okay, because this will be easy to solve these two when we're solving the equation. So we have x minus 4 equals 3, and then x minus 4 equals negative 3. So we agree with Claire's first solution here that x equals 7. Then we just needed to get the other solution here. So we'll add 4 to both sides. So then x equals positive 1 would give us negative 3 squared, which we know is also that positive 9. Number 8, decide if each equation has 0, 1, or 2 solutions and explain how you would know. So you can do this a lot of different ways. So if you wanted to graph this, you certainly could. So if you graphed it using Desmos and then you zoomed out, okay, you would see that this one looks something like this. Maybe you even know that from transformation form that this would just pull it down to negative 144. So then this is going to have 2 solutions because we see it cross the x-axis at 2 places. So that's one way you could think about it. Another way you could think about it is that x squared would have to be 144 for these to subtract to 0. And then we would know that 2 numbers do that, okay, because we have something squared equals a positive number. So we know that there are 2 solutions here. And in fact, they are positive 12 and negative 12. So could have done a couple different ways there. B, then, if we use a similar idea on the graphing, B is plus 144. So x squared plus 144 is going to pull this up. So then we'd see that there's 0 solutions because it doesn't cross the x-axis at all. Okay, so no x-intercepts. Or you could reason that x squared would have to equal negative 144 in order for those to add to 0. And there are no numbers, okay? So no numbers squared can equal a negative number. So there aren't going to be any solutions that will give you x squared equals negative 144. Part C, 0 product property we could use here because we see that we've got 2 numbers multiplied by each other that equals 0. So 0 product property would tell us 2 solutions, right? Because x equals 0 and x minus 5 equals 0, and we would solve each of those. That would give us 2 solutions. And then 0 product property again. So I'm just going to call that ZPP. So 0 product property tells us 1 solution here. Okay, because it's just going to be where x minus 8 equals 0. That's going to be the only solution. Where in this one up here, it was that x equals 0 or x minus 5 equals 0. So we know we'll have two solutions. And then in this last one, again, the zero product property will tell us 2, because it would be x plus 3 equals 0 or x plus 7 equals 0. Those two would produce solutions.